We're going to talk today about hyperbolas and how you spell them. Okay, that's how you spell them. And we're also going to talk about the definition, and we're going to derive it and derive the formula. Hyperbola has foci. You have one here, we'll call that C0. You have another one over here, call it negative C0. X-axis, y-axis. The foci are on the x-axis. The hyperbola will look something like this. Now, for the record, what you see to the left, that is this piece here, it really should be symmetrical to that piece. I didn't do such a hot job doing that, but I'm just telling you it is. Now, how does the point end up being on the hyperbola? For example, this point xy, what is so special about that point? Why is that point on the hyperbola? The answer is because we're going to compute two distances. The distance from that point to one focus and the distance from that point to the other focus. And that distance is always going to equal 2a. So let's just talk about that just a little bit. Let's talk about that right there, that distance right, that point right there. That point right there is, it's on the x-axis, so y is 0. It's r, 0. Let's find out exactly what that point is. Well, like I said, this distance and that distance, when you subtract them, you're supposed to get 2a. Well, the first distance, is always the right point minus the left point. That distance is r minus negative c, minus the other distance, which is c minus r. So this is r plus c minus c minus r. Well, you have plus c, and you subtract them, you get 0. And if you have r, and you take away negative r, you get 2r. Oh, but 2r, whatever we got, that difference is supposed to be 2a. That means r is a. That is, this point right here, the x value is a. And by symmetry, the x value right there is at negative a. Hence, the distance 2a. I mean, if I would have called this a and negative a, I could have concluded that the distance was 2a real quickly. I could have, instead of calling it r, I could have called it a. And I have a plus c minus c minus a. This is 2a. The distance is 2a. That's probably a cleaner way of saying it. So now, let us derive the formula. You know that I didn't mean to say distance. I meant to say difference is 2a, not distance. When you subtract the distances, you get 2a. Okay, so let's draw a little hyperbola here. This is C0, negative C0. It goes something like this. Now, again, this point xy gets to hang out on this hyperbola because this distance, which I'll call d1, minus that distance, which I will call d2, equal twice a. Now distance 1. Well, you subtract the x values, x minus c, you square it, you add on the difference between the y values, y minus 0 is y, you square that, that's d1 minus d2, x value minus x value, x minus a negative c is x plus c, plus y minus 0 is y squared, square root, and this equals 2a. d1 minus d2 is equal to twice a. Just like with the ellipse, if you have two square root signs on the same side of their equality sign, move one to the other side. So we end up with the square root of x minus c squared plus y squared is equal to 2a plus this square root sign. And now we're in a better position to square both sides. And I'm going to get rid of this. Okay. Now, square root. When I square this side, I just get what's underneath the square root sign. I get x minus c squared plus y squared. When I square the right hand side, which is the same, I get that squared, plus I get that squared, which is just what's underneath the square root sign, plus 2 times that, which is 4a, times that, called the middle term. Don't ask why I didn't put it in the middle. Alright, the first thing I would see here is that I can take away y squared from both sides of the equal sign. The next thing I'll see is I have just one term that has the square root sign. And it's on the right side. I'm going to keep it on the right side. I'm going to bring everything to the left side. So I keep this where it is, x minus c squared. I bring this over as minus x plus c squared. I bring this over as minus 4a squared. And I leave this all by itself, ready to be squared. Okay. I have the difference of things being squared. And I had to factor that. First, I add these two, and I get 2x. Then I subtract the 2, and I get minus 2c. Minus 4a squared, and then the rest. Okay, so I get negative. Negative 2 times 2 is 4. Already wrote the 4. Times the c times the x minus the 4a squared, and it equals to the right side. The next thing I notice is that every term is being multiplied by 4. That is, it is a multiple of 4. So I divide the first term by 4, the second term by 4, and the last term by 4. And on the left I get negative, I'll factor it out, cx plus a squared, negative 1 times that, equals a times the square root stuff. When you square the left-hand side, when you square the negative 1, you get 1. And when you square the right-hand side, whatever you get, that 1 times whatever this turns out to be is going to equal what this turns out to be. Multiplying by 1 doesn't do anything. So I get the first squared, c squared x squared, plus 2 times the product of the two terms, a squared cx, plus I get the second term squared. A squared squared, a to the 4th. This equals this squared times this squared, which is just x plus c squared plus y squared. Okay, we're getting there. Almost to the end. Okay, so let's clean up the right side. Since I'm not doing anything to the left side, there's code for, just write it down. Now before I can distribute their a squared, I have to clean up what's in the brackets. That is, I need to square x plus c squared. I get x squared, I get plus 2 times c times x, and then I get the c squared, plus the y squared, that y squared. Okay, now I will distribute the a squared. That is, the right side, nothing happens to it. I get a squared x squared. I get 2cx times a squared. I get a squared c squared. And lastly, I get a squared y squared. Now, I'm going to bring everything that has x squares and y squares to the left and everything else to the right. But to be honest, before I do that, I am going to notice that one, I have an error. When I square this, I'm supposed to get 2 times a squared times c squared. I just wrote down a squared times c squared. Supposed to get 2 times that. Sorry about that. And then I notice on the left side of the equal sign, I have plus 2a squared c squared. And on the right side, I have plus 2a squared c squared. That is, they cancel out. And now I'm going to do what I promised. I'm going to keep this on the left side because it has an x squared. I'm going to move this to the left side as minus a squared x squared. I'm going to move this to the left side as minus a squared y squared. The a squared c squared can stay on the right side, and this a to the 4th becomes minus a to the 4th. On the left side, I have c squared x squares, and I'm taking away a squared x squares. So I have c squared minus a squared x squares minus a squared y squared. On the left side, I can pull out an a squared. Remember, a to the 4th is a squared times a squared. So I factor out a squared, and then what's left over, that is what I didn't cross out, I write down. I didn't cross out c squared, I didn't cross out a minus sign, and I didn't cross off that a squared. Okay. Now, just to make things look nice looking, instead of the c squared minus a squared, I'm going to say, you know what, everyone? Let that be b squared. Okay, so I have b squared x squared minus a squared y squared, and this is a squared times, oh, this b squared again. Okay, now we're done. I divide both sides by a squared b squared, which means I divide every term by a squared b squared. That cancels out, and I'm left with x squared over a squared minus this canceled out, and I'm left with y squared over b squared, and that's 1. That is the general equation of a hyperbola centered at the origin, but the two foci are on the x-axis. And oops, I drew this one wrong. Should go like this. Now, you can see that their focus on the right is like inside this piece. It's not over here. And for this piece, the foci is inside. Now, if you notice, I'm allowing y to be 0. Y is 0 here. X is never 0. X is never 0. You never cross this point. Okay, and the reason is, if x were 0, then that would be 0. And this piece is either 0 or positive. Let's suppose it's positive. So now you have 0 minus a positive quantity equaling 1. And if you have 0 when you take away a positive quantity, you never get 1. 0 take away k is a 1. That means k equals negative 1. But I'm telling you that this quantity is positive. You can't have k be a negative 1. This can't be negative 1. Only 0 minus a negative 1 gives us 1. This can't be negative. That is, x can't be 0. And the letter that can't be 0, that's the one that has the foci on it. Just remember that you have this relationship. You have that relationship. That the b squared in the formula, you come down a moment. When you have x squared over a squared minus y squared over b squared equal 1, and you're told what c equals, c can be 3 maybe. That means the foci is at 3 and at negative 3. Just remember that b squared came from c squared minus a squared. This is this distance squared minus that difference squared. Think about what that might mean. Okay, there is your derivation for the hyperbola along where the foci are along the x-axis. Now let me just say one last thing. If I were to reverse x and y, if I had y squared over a squared minus x squared over b squared equal 1, well, we're just playing games. We are just playing games. I interchanged x and y. It looks like this. This will be negative c. This will be positive c. This point will be negative a. This point will be positive a. And again, this distance squared minus this distance squared is gonna be b squared. Okay, so there's no big deal going from one to the other. I mean, basically, I wish I can do it with my software. But basically, take this graph and rotate it 90 degrees. Just rotate it and see what happens. I'm sure I can do it, I just forget how. Okay, so all you have to do is rotate this here, where this x ends up here, and that y ends up over here. So it would be more than a rotation, but because it's symmetry, you can just rotate it. Okay, good luck with this stuff. Thank you.